All right, guys, today we're going through the practice 2.2 to 2.5. Everything on this worksheet should be done without a calculator. You want to make sure you're practicing your homework without a calculator so that all of those little computational skills are getting sharpened throughout the year. Use limit notation to describe left and right end behavior. So this is in our notes packet toward the beginning. But if I want to talk about left first, I say the limit as x approaches negative infinity, so that means left, of f of x equals, what's happening here on this graph? Let's see. It's x to the fourth. Positive x to the fourth means up on the right, and the left side does the same. So how do I say up on the left? I say that this limit equals positive infinity. And the limit as x approaches infinity, this is the right, of f of x, what does it equal? The right side is also going up. So order doesn't matter here. Obviously, if left and right are different, you need to pay attention to which one you're talking about. Find the zeros, write the multiplicity at each. So set your function equal to 0, start factoring. This is a trinomial, so we're saying x to the fourth gets split into x squared and x squared. 4 is 4 times 1. To make it add to negative 3, I do minus 4 plus 1. Now, you don't have to, this doesn't say write the linear factorization. So when you're solving for this, you can just start solving. X squared equals 4. X squared equals negative 1. That means that x equals plus or minus 2. And x equals plus or minus I. All 4 of those zeros have a multiplicity of 1. Because if I did keep factoring them, I would get x plus 2, x minus 2, x plus I, x minus I. Each of those factors shows up once. What that means for our graph is that when we graph plus or minus 2, the graph is going to change signs at those values. Find the y-intercept. For any function, that means plug in 0 for x. If you plug in 0, you get 0 minus 3 times 0 minus 4. It's equal to negative 4. Even, odd, or neither. You can decide this once you get the graph if it helps, but all of the exponents are even, so it's going to be even. But also even means y-axis symmetry. So let's graph and see if this has y-axis symmetry. So to graph, you need to plot the zeros, plus and minus 2. We can't plot imaginary numbers on our real number system, so nothing there. We can plot 0, negative 4. And you need to plot, the rule for how many points you have is you need to plot any points that are integer values in between points that we already have so that you can figure out the height. Because I don't know right now, does this look like a parabola or is it one of these W-shaped things or what? So plug in f of negative 1. When you raise negative 1 to the fourth, you get 1. Minus 3 times when you square negative 1, you get 1. Minus 4. 1 minus 3 is negative 2. Minus 4 is negative 6. F of 1 is going to be the same thing. That's another indication that we have an even function. So if we go down to negative 6, this is kind of like a W-type shape graph. If you drew in your end behavior first, that's okay, but just make sure that your graph looks normal. I had some people who drew in their end behavior like this and then drew in their like W shape and it just didn't look right. So make sure you have a smooth graph. Okay, so yes, this has y-axis symmetry. So this is another indication that the graph is even. Also, you could test that f of negative x is equal to f of x. Domain and range, again, use the graph to help you. This is a polynomial function, so domain is all reals. The range, we have a bottom to a top, so negative 6 to infinity. Name one interval, if any, where the rate of change, the slope, is positive and increasing. So this is from last chapter. I'm going to keep bringing this type of question back all throughout the year. It's really common for AP. Same with domain and range. So remember what this means. If something has a positive slope, it means that f, our function, we're looking for a section of the graph that's increasing. And if the slopes are positive and increasing, those are going to be concave up. Anytime the slope is increasing, you're looking for a concave up section. I want something that looks like this. So I see that happening right here. I do see another spot that's happening, like right here, but at some point concavity switches. So I don't know what this point is without any calculus. So that's why I said, let's just name one interval. So the one we know for sure is positive 1 to infinity. Use the x values. You're giving me like a little mini domain, sort of. Use the x value to indicate where the graph is concave up and increasing. All right, second graph. Note that the x cubed is the second term. It's not always the first term that has the highest degree. Use limit notation again to describe the left and right end behavior. So this graph has a negative leading coefficient, which means the right side goes down. Has an odd exponent, which means the left side goes up. And so translating that into limit notation, I always start with the left. The limit as x approaches negative infinity of g of x is equal to infinity. The graph is going up. And the limit as x approaches infinity of g of x is equal to negative infinity because the graph is going down. Find the zeros and write the multiplicity for each. So set this equal to 0. We can factor out an x squared to get us 3 minus x. So the zeros are x equals 0 and x equals 3. 0 has a multiplicity of 2 because it came from a factor that was squared. And 3 has a multiplicity of 1 because it's factors to the first power. It only shows up once. Multiplicity is another way of saying, like, this is degree 3. There's supposed to be 3 zeros. 0 counts for 2 of the zeros, and 3 counts for another one. Find the y-intercept, find g of 0. If you plug in 0, you get 3 times 0 minus 0. So 0, 0 is the y-intercept. Even, odd, or neither. The answer is going to be neither because I see that there are both even and odd exponents in the function, so that's got to be neither. But also this will be not y-axis and not origin. That would be odd. Symmetry. You don't have to explain to me. I'm just doing that for the video. That's what we'll be looking at on the graph. So if we plot some points, we can plot 0. We can plot 3. Remember, when the multiplicity is even, the graph should be not changing signs at 0. So we know the graph is going to go up on the left and down on the right. We know that the graph is going to touch and turn or bounce, whatever you want to say, not change signs. It's going to stay positive right here. But we need to know the exact height. So we need to plug in g of 1 and g of 2. So if you plug 1 into g of x, I'm trying to erase this. There we go. If you plug 1 into g of x, you get 3 times 1 minus 1, which is 2. And if you plug in 2, you get 3 times 4 minus 8. 12 minus 8 is 4. And we try to connect this with a smooth curve. Again, my end behavior looks a little weird. The curvature is a little weird. So I'm just going to make that adjustment. Oh gosh, that didn't help. To make it look a little more smooth. Something like that. Domain and range. This is polynomials, so domain is all reals. Range is also all reals. These arrows extend both up and down. There's no bottom point. There's no max or min. Name the intervals, if any, on which the rate of change is negative, which means when is G decreasing, and when is the rate of change is decreasing when G is concave down. We're looking for something like that, decreasing, concave down. So that's got to be, the only decreasing section is to the left and to the right. We're concave up over here, but we're concave down right here. So this is going to be 2 to infinity. All right. Find the average rate of change on the interval -1 to 2 for f of x. This is the same f of x we had up here. So I want to remind you what average rate of change means. I know that I have you guys pretty well trained to know that that's slope. But remember, visually what this is saying is from -1, from x equals -1, so like here, here, to x equals 2, it's saying find this slope of this line. That's all the average rate of change is, okay? So we can do this algebraically, or we have the graph, so you could do it graphically as well. But just to get this formula down, that means slope is change in y over change in x. Change in y would be like f of 2 minus f of -1. Plugging those two numbers in would give you the y values at each coordinate. And then delta x would be 2 minus -1. All right, so what is f of 2? Well, we did find f of 2 before, right? We have f of 2. f of 2 is 0. So you could recalculate 16 minus 3 times 4 minus 4, but that's 0. And then f of -1 is also calculated. We got -6 for that. So if you hadn't calculated it before, you'd be plugging those numbers into this function. 2 plus 1 is 3. This is positive 6 over 3. So I got that the average rate of change is 2. Again, you can confirm that. Check out the slope from this point to this point. Is it a slope of 2? Yeah, if you go up 2 and over 1, you get to that point. Find the average rate of change between x equals -2 and 2. For g of x, I just changed up the wording on this. This means the same thing though. So we're going to say the slope is the difference in the y values, g of 2 minus g of -2, over the difference in the x values, 2 minus -2. Let's see, did we find g of 2? We have g of 2 is 4. I don't think I did find g of -2. I don't have that plotted, so I do need to plug that in. Excuse me. So use parentheses when you're doing this. 4 minus, okay, so 3 times -2 squared is 4. Minus -2 cubed is -8. And then over 2 plus 2. So let's see, what is this? 12 plus 8 is 20. 4 minus 20 over 4. -16 over 4 is a slope of -4. Now, I don't have the point -220 on here, but what we're saying is, yeah, at -2, if the point's way up here, and then we're going to x equals +2 here, we're saying the slope is -4, the slope between these points. The remainder theorem. This is a nice, convenient theorem. It uses synthetic division. It gives you a second way to evaluate. So evaluate h of 4 the old way, which is still valid, by the way, still my main method of calculation, is to do 2 times 4 cubed minus 3 times 4 squared plus 4 minus 2. But sometimes this math can get kind of cumbersome, right? You're raising things to exponents, multiplying, subtracting, adding. So the other way to do it, our new way, is this remainder theorem. We can put 4 outside of synthetic division, and whatever you're left with in the remainder spot is the answer for h of 4. And why does that work? Without doing a big formal proof, remember when we put in a number that we know is a 0, something that divides perfectly into a function, we get 0 in the remainder spot. So that is the function value as well. So that's kind of a connection you can make. So when I plug in 4, I should get, after doing synthetic division, whatever this answer is. So drop down the 2, multiply, add, multiply, add, multiply, add. So h of 4 is 82. I'm not going to check it with the old way, but you could double check. 2 times 64 minus 3 times 16 plus 4 minus 2 should also be 82. Okay, let's do it again. So again, we could just plug in -3 in for all 3 of these x's, or we can use synthetic division. Beware of placeholders. -1x to the 4th, 3x to the 3rd, 0x squared, -1x. There's no constant. You need to have a constant as well. Drop down the -1, multiply, add, multiply, add, multiply. Hey, if you ever get mixed up multiplying, by the way, it's easy to make mistakes like this. 18 is 10 plus 8. Let the distributive property work for you, right? This is all valid math, right? 3 times 18 is the same as 3 times 10 plus 8. I know 3 times 10. I know 3 times 8. I can add those together, right? And that is what you're doing when you do the carryover method and whatever. It's just this sometimes is easier to keep track of. So that was me multiplying. Now I'm adding. I'm going to do the same thing here. 3 times 50 plus 3. That's 150 plus 9, 159. Negative. I have to be aware of that. This is negative. My other one was a negative times a negative, so it's positive. My remainder was -159, so f of -3 is -159. So it's not that you won't have to deal with big numbers, but only multiplying and adding instead of raising to a power and multiplying and adding is one less step. So that's why remainder theorem exists. It's kind of a nice, faster way to evaluate. Okay, imaginary numbers. Make sure that you have memorized that I squared is -1, I cubed is -I the 4th is 1. If you do not have that memorized, square root of -1 is I. If you don't have these 4 memorized, you're going to struggle in this section. So take the time to study it. However, you need to get that pattern down. You can also figure them out, right? Like I cubed is I squared times I. So if you know I squared, you can kind of get around to the rest of them. All right, this first one, we're just simplifying each complex expression. So 3 minus 5i minus 16 plus 12i. Write your answer in standard form, meaning put the real number first and the imaginary number second. We're leaving our answers in terms of I, so we're not going to replace this with square root of -1. For the next one, I need to rationalize. Can't have an I in a denominator. Multiply by I over I. That's 20i plus 4i squared over 5i squared. The reason this works is because you get -1s for the I squared, so -4 plus 20i over -5. You can leave your answer like that. You could separate it into 4/5 minus 4i if you'd like to. Higher powers of I. Remember, this pattern repeats every 4, and I to the 4th is 1, which is a nice, easy number to work with. So if you divide each exponent by 4 and figure out what the remainder would be, the remainder should land you on which I that you should be simplifying to. So 4 goes into 80 20 times, right? That gets you up to 80. And then you're left with an extra little remainder of 3 over 4. So it's the remainder that's important. And 61 divided by 4 for this exponent. 4 goes into 60 15 times, and you have a remainder of 1. So it's the 1 that's important. So you can rewrite this problem and say, instead of 3i to the 83rd, it's really like 3i to the third. That's equivalent. Instead of 3i to the 61st, it's really just like 3i to the first. And we know that I cubed is negative I. So negative 3i minus 3i is equal to negative 6i. For the radical problems, simplify the radical first, get the negative out of there and work with the radicals. So 64 is 4 times 6. That means that this is 2i radical 6. 12 is 4 times 3. That means this is 2i radical 3. Multiply these together. You get 4i squared radical 18. 4i squared is negative 4. Radical 18 is 3 radical 2 because it's 9 times 2. Oops. And so I get negative 12 radical 2. For number 11, again, I have an I in the denominator. Because this is a binomial, this is two terms, you have to multiply by the conjugate. You can't just do I over I. And we've got some foiling to do. 3 times 2 is 6. 3 times 3 is 9i. 4 times 2 is 8i. 4i times 3i is plus 12i squared. In the denominator, 2 times 2 is 4. 3i, negative 3i times 3i is minus 9i squared. 6 minus 12 is negative 6. 9 plus 18 is 17i. 4 plus 9 is 13. For number 12, I want to square the binomial, but before I can do that, I need to rewrite the radical. So this is 3 plus I radical 6. When we square that binomial, you get 3 times 3 is 9. You're going to get plus 3i radical 6 plus another 3i radical 6. That's plus 6i radical 6. Plus I squared times radical 6 times radical 6. 9 minus 6 is 3. There's nothing to simplify on 6i radical 6. Okay. Now for this section, write the linear factorization for each function and find all zeros in the complex number system. Remember, the complex number system is real and imaginary. Linear factorization means we're not stopping at x squared or anything like that. We've got to get it down to x, x, x. So to begin, I like to begin with finding the zeros. Remember, that's what we did in our notes. So set this equal to 0 and start factoring. It's a trinomial, so x squared, x squared. Factors of negative 8 would be plus 4 minus 2 to give us 2 in the middle. And then normally we would stop at x squared plus 4 when we're factoring, but we're going to go ahead and find the zeros for each of these. So x squared could equal negative 4 or x squared could equal 2. Square root. X can equal plus or minus 2i, or x can equal plus or minus radical 2. So these are all the complex zeros. To write the linear factorization, make sure you write f of x equals, and then it's x, it doesn't matter what order, but x plus 2i, x minus 2i, x plus radical 2, x minus radical 2. And that's the linear factorization. On a speed quiz, we would just leave our answer back on this first line because it doesn't factor nicely. But linear factorization is breaking it down like this. It says if you have degree 4, you should have 4 factors showing. All right, next one, let's find the zeros first. I can do that by adding 15 to the other side, square rooting both sides. Okay, and so these are the zeros. And then to write the linear factorization, this one's y. So y equals x plus radical 15, x minus radical 15. And for number 15, find the zeros first. I can factor. This is a difference of squares. 2x squared plus 5, 2x squared minus 5. Now we have some two options here. When you're solving, you can say x squared equals negative 5 over 2. X squared equals 5 over 2. Or you could say 2x squared equals negative 5, 2x squared equals 5. Square root from there. But this is probably what most of you are going to do. Okay, so we do this. We square root. X equals plus or minus I radical 5 over radical 2. X equals plus or minus radical 5 over radical 2. The simplifying of the radicals and stuff, this is it. I have not been counting off for this, but I think a lot of you are starting to forget that square root of a fraction is actually this and can be rationalized. I'm getting a lot of questions about where did that radical 10 come from, which makes me a little nervous. So it came from me saying rationalize, multiply by radical 2 over radical 2. That's all I did there. Okay, so whether you leave your answer in terms of the 5 and the 2 or the 10 and the 2, whatever, but here's our factorization. So these are the zeros. We have to be careful with this factorization. It's not just, actually, hold on. I need more room to write this. We have 4 factors. It's not just x plus I radical 10 over 2, x minus, x plus, radical 10 over 2, x minus. This is almost the right answer, but not quite. If I FOIL this back together, I'm only going to get x to the 4th plus some other stuff. I'm supposed to get 4x to the 4th. So how do you remedy that? You just make sure that you put a 4 out in front, right? Okay, so you've got to make sure that you include this because of the fact that there is a 4 here. Here, this one. I didn't have to worry about that in the other two. They were just x to the first power. Find the zeros of f of x. It doesn't say complex zeros, but it doesn't say real zeros only. So now our world is complex unless told otherwise. So find all the zeros given that x plus 2 is a factor. I can't factor this on its own. It doesn't factor by grouping. So I'm going to choose to do synthetic division. Negative 2 is a factor, so if I've done my math correctly, I should get 0 right here. So drop down the 1, multiply, add, multiply, add, multiply, add. That checks out. Remember what you're left with? You just divided a cubic by a linear, left with a quadratic. So we know f of x is equal to x plus 2 times x squared plus 3x minus 18. We're trying to find the zeros, and the good news is that this factors into x plus 6, x minus 3. So the zeros are negative 2, negative 6, and positive 3. For the next one, this says find the zeros of this f of x, given that plus and minus I are zeros of f of x, excuse me. So we're not going to put I outside of the synthetic division. That would get complicated. But we can square both sides and say, well, x squared equals I squared if I square both sides. In other words, x squared equals negative 1. That's how we got the plus or minus I. That means a factor was x squared plus 1. That's the factor. That means that we should be able to divide f of x by x squared plus 0x plus 1. We have to do long division because we have a quadratic that we're dividing. So I can multiply x squared by x squared. Makes this x to the fourth plus 0x to the third plus x squared. Subtract. Negative 2 minus 0 is negative 2x cubed. 2 minus 1 is plus x squared. Drop down the minus 2x. Repeat, so x squared gets multiplied by negative 2x to get negative 2x cubed. Negative 2x times 0 is plus 0x squared. Negative 2x times 1 minus 2x. These cancel. 1 minus 0 is 1x squared. Negative 2 plus 2 is 0x. Drop down the plus 1. Multiply x squared by 1 to get x squared plus 0x plus 1. I should be getting 0 there, right? That should be happening. So here's what we know. F of x is equal to this factor that we figured out from the zeros times x squared minus 2x plus 1. And I guess I was nice to you guys on this one. I didn't need quadratic formula for either of these two. So this factors into x minus 1 times itself. So the zeros are plus or minus I, which they gave me. Don't forget about those. And also positive 1. Write a polynomial function equation in general form, that's this one, FOILed out, that fits the given information. On my answer key, I think I forgot to incorporate the negative. So degree 3, zeros are 0 and 3i, so really plus or minus 3i. And the limit as x approaches negative infinity, so on the left, the graph goes down. And it's degree 3, so on the right, the graph goes up. Okay. So for this one, now the graph goes up on the right, so there's no negative to force into this. So actually, when I say I think I had a mistake on my key, maybe not. I can't remember if I didn't do this for number 19 or what. Okay, so f of x is what I'm going to call mine. We don't need to include a negative sign or any other a value to fit a point. The zeros would be coming from a factor of x. And if I'm getting plus or minus 3i, that came from x squared plus 9. So general form would just make this f of x equals x cubed plus 9x. For the next one, the degree is 4. The zeros are 0 with a multiplicity of 2. And 2 minus 3i, or 2 minus radical 3, so also 2 plus radical 3. The limit as x approaches infinity, so on the right side, the graph is going down. The left side would also be going down. We need a negative included in this one. Excuse me. This might be the one I forgot to do the negative piece in my key. Let's call this f of x again. We need a negative. 0 came from a multiplicity of 2, so x, oops. I almost wrote x minus 0. You can write x minus 0 or just x squared. And then the other zeros were x minus 2 plus radical 3, x minus 2 minus radical 3. And remember, the quick way to multiply these is to see that these are conjugates, which means you don't have to FOIL a trinomial times a trinomial. You can say this negative x squared is the last thing we'll take care of. This becomes x minus 2 squared minus radical 3 squared. So negative x squared is still out there. X squared minus 4x plus 4. Radical 3 squared is 3, so minus 3. Negative x squared times x squared minus 4x plus 1. And finally, distributing that negative x squared through, negative x to the fourth plus 4x minus x squared. Actually, I want to look back at my key to see. Yeah, I forgot the negative piece here, so I will have to go back and fix that. Distribute a negative through. Okay. Next one. This is the long type of problem. with the point that we have to satisfy. So degree 4, zeros are I radical 3, so really plus or minus I radical 3, and 1 and negative 4. And we have to get the point 0, negative 6 on there. So when x is 0, y is negative 6. Remember, this means find a. When you set this up, you need to put an a coefficient out here. That'll be sort of a mystery until we get it sorted out. Let's get the real numbers out of the way. X minus 1, x plus 4. What about this I radical 3? If x equals plus or minus I radical 3, you can always figure out the factor by squaring both sides. You get I squared times 3. That would be x squared equals negative 3. So that came from x squared plus 3. All right. And at this point, I wouldn't FOIL anything else together. I would plug in my numbers. So I would say negative 6 equals a times, we're just plugging in 0 for x. So like this. Negative 1 times 4 times 3 is negative 12. Negative 6 divided by negative 12 is 1/2. Okay, and then we carry on. So f of x is 1/2 times, let's do x minus 1 times x plus 4. X squared plus 3x minus 4. X squared plus 3. All right, and so I've got x to the 4th. This I do just kind of have to distribute through. Plus 3x squared plus 3x to the 3rd plus 9x minus 4x squared minus 12. Let's take the 1/2 through last. X to the 4th plus 3x to the 3rd. So I did those. I've got negative x squared plus 9x minus 12. You could multiply the 1/2 through. You could also just not. Everything would just be times 1/2. So actually, I'm just going to leave it like that. That's the only thing I would say, yeah, to be in general form. I don't care if you have a coefficient factored out in front. I just don't want any of the x's to still be factored out. And that was our last problem. All right, so if you're having trouble with any of this or if you have questions on any of these problems, please make sure that you come into office hours next week. Our test is on Friday.